Okay, determine whether the triangles are similar. Since all we have are side lengths, then for number 10, we're going to have to set it up and test it using side similarity theorem. So let's see what we've got. We are going to try and match the smallest side on each triangle. So we've got, this is 32 and this is 22. That's what we'll be matching. We'll say 22 over 32, and we're going to check that that's the same as the middle length side, 45 and 30. And since we have the small triangle on top, 22 is on top, so we'll have 30 on top over 45. And finally, we'll say the longest side, 40 over 60. And we need to simplify all these and see if we get the same. So what I need to do here is I need to simplify these ratios. So 22 over 32, I can divide them both by 2 to get 11 over 16. 11 is prime, so that's as small as it's going to get unless 16 was divisible by 11, but it's not. Okay. When I simplify the green ones, I get 30 over 45 simplifies to, by dividing both by 15, to 2 over 3. Clearly not going to work, right? And then 40 over 60, that simplifies to also 2/3. So that's great, except for the dark purple or the violet, whatever, sides 22 and 32. They don't simplify down to 2/3. Pretty close, but not quite. So we can say not similar. Okay, we're going to do the same thing. Now, we need to know that the angles are the same in triangles in order for them to be similar. So what we're going to do is figure out what that third angle is for each of these. So for here, we're going to say, okay, well, let's add 25 plus 35, the two angles that we do know, is 60. And then let's take that away from 180 to find out what needs to be left. So that angle needs to be 120 degrees. Okay, and we'll do the same thing for this one. In order to find out what that angle is, we'd have to add 110 and 35. What we're checking is to see that we actually do have the same angles on these. That's 145. So then we do 180 minus 145. And that angle is 35 degrees. Do we have the same angles? No. We have 35, 25, and 120. And the one on the right is 35, 35, and 110. What are we going to say? We're going to say that these are also not similar. Okay? And for this one, we're going to compare, just like we did before. I'll use those same colors as we did before to kind of compare sides. We've got some short side, 9 on this one, 18 on this one. Short side, 9 over 18. We've got the middle length side, 11 here, over the middle length side, 22. 11 over 22. And for this longest side, 12 over 24. And if you're comfortable with fractions, comfortable with numbers, you might already be able to see that these simplify down to 1/2, 1/2, 1/2. So, are the triangles similar? Yes. If so, write a similarity statement. Okay. They're similar. I'm going to erase the marks that are up top and just be able to take a look at the numbers and the angles. Okay. Let's see. We've got which vertex is between the two smaller sides? Well, on the small triangle, 9 and 11 are the two smaller sides, and that's G. And on the big one, the two smaller sides are 18 and 22, and that's C. So we know that triangle C is going to match with C. Let's do the same thing all the way around. Which one matches with between the two larger sides? 11 and 12 is K, and for the big triangle, between 22 and 24 is B. That's those. And the last one, what is the vertex between the smallest side and the largest side? That's H for this triangle, and it's A for this triangle. So then we can match them up to say, okay, if we said triangle ABC is similar to triangle, what matches with A? H. What matches with B? K. And what matches with C? G. So that's the congruent statement. As long as you match the correct vertices, it doesn't matter which order the letters are in, they just have to be in the proper order for the second one as well. And what postulate or theorem that we used? We can say we used side, side, side. Similarity. Done. Oh, actually, and you know what it does? It asks us to explain. So I'm going to explain on these because I didn't sufficiently explain the first two. So we would say not same ratio of sides, sides not in proportion. And for this one, we could say, it says, well, we could say not similar, all angles not congruent. Or let's just say angles not congruent in both triangles. And two triangles.